Hello everyone. In this video, we are going to talk about derivatives. So what are derivatives? Actually, if we have a function, then the derivative of a function f is the function which gives the slope of the tangent line to the graph of f of x at the point x. So the derivative of f of x is denoted by f prime of x. This is the notation for f, derivative of f. And by the derivative, as we have just said, it means the tangent line, it means the slope of the tangent line to the graph of f of x at the point x. So if the slope is m, then we say the derivative of f at this point x is equal to m. So then the next question, which is natural to ask, is how do we find the slope of a tangent line to the graph of a function at a point x equals a? We know that if 2 points like x1, y1 and x2, y2 are given, then we can write the equation of the line passing through them in the following way. The slope of the line is equal to y2 minus y1 over x2 minus x1. So taking either of these points, x1, y1 or x2, y2, we can write the equation in the way of y minus y1 equals the slope times x minus x1, or y minus y2 equals the slope times x minus x2. So both give the equation of this line, which is shown in this picture. So if we come back to our question, we know only one point on the tangent line to the graph of f of x at x equals n, and this point is f of a. This is the coordinates of the point we know. But we don't know a second point. So actually, this is where we use our idea of limit. We take the second point on the graph of the function f, which is only h units away from this point a f of a. So then this point has the coordinates a plus h, f of a plus h. Then the slope of the line between these 2 points is equal to this, f of a plus h minus f of a over a plus h minus a, which is equal to, when we simplify a minus a, f of a plus h minus f of a over h. And then we take the limit of this slope expression when h goes to 0 or h gets smaller and smaller. The slope formula here will give the slope of the tangent line. So making h smaller and smaller means we are going to make the second point, a plus h, f of a plus h, get closer and closer to the first point. So the slope we find by taking the limit will give a very nice approximation to the slope of the tangent line at the point a f of a. So this is how we define the derivative. F prime of a, which is the slope of the tangent line to the graph of f of x at the point a f of a, is equal to the limit of the slope expression when h goes to 0. So looking back to the picture here, we have the point a f of a, and then we have a second point on the graph, a plus h, f of a plus h. The slope between them is given in the limit formula. Making h go to 0 or making h get smaller or smaller means making the second point get closer and closer to the original point. So the slope of the approximation line will be getting closer and closer to the slope of the tangent line. This is how we obtain the derivative. So the derivative, if we have a function f of x, the derivative of f of x, which is f prime, is actually the slope of the tangent line to the graph of f of x at the point x f of x. This is actually the geometric meaning of derivative. And algebraically, it's given by this formula, limit h goes to 0, f of x plus h minus f of x over h. And this is algebraic formula of derivative, or the limit definition of derivative. And practically, the meaning of derivative is the instantaneous rate of change of f of x at the point x f of x. And this definition is actually for any general point x f of x in the domain of the function wherever this limit exists. So at a specific point a f of a, this is a definition. Let f of x be given, and a is in the domain of f, then f prime of a is equal to the slope of the tangent line to the graph of f of x at the point a f of a, which is this limit expression, h goes to 0, f of a plus h minus f of a over h. If this limit exists, then f is said to be differentiable at this point x equals a. So there's an equivalent definition to this definition, which is if f is given and a and x are in the domain of f, then the derivative of f at the point x equals a is f prime of a is equal to, now this time we say limit x goes to a, which is the limit of f of x minus f of a over x minus a. So what's this expression here? Like if we take our first point a f of a, and if we take the second point x f of x, which is a second point on the graph, so then the slope between these 2 points is f of x minus f of a over x minus a, which is the slope of the line between these 2 points. So by making x get closer and closer to a, the slope will be giving us a better approximation to the slope of the tangent line, because we are going to be making the second point x f of x get closer and closer to the original point. So if this limit exists, then we say f is differentiable at the point a. Here is an example. Find the slope of the tangent line to the graph of x squared at x equals 1. Then f prime of 1 is actually the slope of the tangent line to the graph of x squared at x equals 1. And then that's equal to the limit definition here. H as h goes to 0, f of 1 plus h minus f of 1 over h. But f is x squared function, so it takes the square of 1 plus h and 1. And then when we place them into the limit expression here, opening the expression 1 plus h squared as 1 plus, which is actually 1 squared plus 2 times 1 times h plus h squared minus 1 over h, plus 1 minus 1 simplifies, and then we have 2h plus h squared over h, and when h goes to 0, this is going to be 0 over 0. So in this case, if we have a 0 over 0, we factor h and simplify. So if we factor h on the top, then we are going to have h times 2 plus h over h times 1 on the bottom. Cancel the h's, simplify them with each other. Then we have limit h goes to 0, 2 plus h. So h goes to 0 will be giving us 2 plus 0, which is 2. So this is the slope of the tangent line to the graph of x squared at x equals 1. Okay. Now, let's get the same result using the second definition of derivative. So f prime of 1 with the second definition is equal to limit x goes to 1, f of x minus f of 1 over x minus 1. So f function takes the square of the input, so x squared minus 1 squared over x minus 1. We take the limit of this expression as x goes to 1. But that gives us, when we take the limit, 0 over 0. So if we factor here x minus 1 on the top and simplify with the x minus 1 at the bottom, we are going to have limit of x plus 1 when x goes to 1. So that is equal to 1 plus 1, which is also 2. As you see, that gives, both definitions give the same slope because they are equivalent anyway. Here is another example. Find an equation for the tangent line to the graph of f of x equals x squared minus 3x plus 5 at the point x equals 2. First, we need to find the slope of the tangent line to the graph of this function. So we write f prime of 2 equals limit x goes to 2, f of x minus f of 2 over x minus 2. And then we write f, which is x squared minus 3x plus 5, minus, we put 2 into the function, which gives this expression 2 squared minus 3 times 2 plus 5, all over x minus 2. So if we simplify the numbers here, the top will be x squared minus 3x plus 2 all over x minus 2. So if we take the limit of this expression, we are going to have 0 over 0. So what do we do in the 0 over 0 cases? We factor something and then we simplify. Of course, we need to factor x minus 2 because if we can factor x minus 2 on the top, then we can simplify it with x minus 2 on the bottom. And exactly, we can factor x minus 2 on the top. So when we simplify the x minus 2's, we have the expression limit of x minus 1 as x goes to 2, which is 2 minus 1, that's equal to 1. So we know now the slope of the tangent line, which is equal to 1, and the x-coordinate of the point is already 2. We know x is 2. The x-coordinate of the point is 2. What is the y-coordinate? That's f of 2, which is plus 3. So now we know the point and the slope. Slope is 1. Coordinates of the point is 2 and 3. So then we can just write the equation of the line with slope 1 passing to the point 2, 3, which is y minus 3 equals 1 times x minus 2. And if we simplify, it will be equal to y equals x plus 1. And if we draw a graph of the function and the tangent line, it's going to look like this. So this is the end of this video.